Alright, this is a quick lesson on Chapter 4, Lessons 1 and 2. I want to review fraction to decimal percent. Remember, this is different looks at a number. I've talked about the percent as being a selfie of a number, decimal form, and of course fraction form. So to review, to be able to convert all the way through here, a fraction is simply a division problem. So divide, top number goes in the box, bounce that decimal 2 places right, and it becomes a percent, which means you've taken it times 100. If you want to go reverse that to take your percent, move the decimal 2 places to the left, that means you're dividing it by 100, which is exactly what percent means, divide by 100. And then if you read it using place value, it will sound like a fraction. You can write it as a fraction. The overall lesson for this unit, for Chapter 4, is rational numbers, which rational numbers are numbers that can be written as a fraction. This one right here, read it, works for everything except for repeating decimals. We'll have to work on repeating decimals just a little bit differently. But remember, if you divide a fraction, it will either terminate or it will start repeating. So I'm going to do the guided practice off page 266. Number 1 says 2/5, and it wants me to write it as a decimal. So let me do number 1, 2/5. Remember, this is a division problem. 2 divided by 5. Top number goes in the box. Put out a decimal, put some zeros. Bring the decimal straight up, and 5 will not go into 2, but it will go into 24 times. So it became 0.4 as a decimal. I'm going to go ahead, even though it didn't ask for it, I'm going to also change it to a percent by moving the decimal 2 places right. So that would be 40%. Try number 2, negative 9/10. Notice there's only one negative, so I already know my answer is going to be negative. But I will be doing top number divided by bottom number. Top number goes in the box. Put out some zeros. Does not go into 9, but goes into 90. So it's 0.9 negative, because we already knew it had one negative. That'd be, if I changed it, it'd be negative, move it 2 places, 90%. That'd be like a decrease of 90%. Number 3, 5/9. Remember, it's a division problem. Going from fraction to decimal, divide. Top number goes in the box. Put out some zeros. This time when I divide, it goes in there 5 times, minus 45. I get 5 again. Looks like I'm going to be doing the exact same problem again. If I subtract again, I get 5. I'm going to be repeating this. This I would write as 0.5 with a line over it, which notice that this is a repeating decimal. If I move that decimal 2 places, be careful, because you might think, well, it's going to be 50. But no, these are a whole bunch of 5s. So if I moved it, I'll show you that. If I moved it 2 places, it'd be 55.5 repeating percent. Number 4 says during a hockey game, an ice resurfacer travels 0.75 miles. 0.75 miles, and we're going to write that as a fraction. Now look, I'm going from a decimal back to a fraction, so my rule is I need to read it. So let me read that by its place value. It ends in the hundredths, so I would read that as 75 hundredths. And then, of course, at that point I could simplify it. I see 25 goes into both of them, so let me divide by 25 over 25, which gets me 3/4. So as a fraction, that would be 3/4. Alright, let me do a couple problems off of page 274 as well. Page 274 is talking about comparing these. So let me talk about comparing fractions, decimals, and percents. First of all, you need them all in the same form. So if there are fractions, decimals, and percents, either go to all fraction, all decimal, or all percent. So be careful with negatives especially. The first one has a common denominator. This number 1 off page... Oops, I'm on the wrong page, excuse me. Page 274. On 274 it says negative 4/5, and I'm comparing that to negative 1/5. So I'm in the negatives. I'm in a common denominator, which you have to be in a common denominator to compare fractions anyway. So let me draw a picture of this. If this was 0 and this was negative 1, and I'm in fifths, here would be negative 1/5. Here would be negative 4/5. The problem is negative 4/5 sounds bigger, but which one's actually to the right? Negative 1/5. So I would say that negative 4/5 is, that's the less than sign by the way, is less than negative 1/5. The next one is in the positive, so we'll better be able to understand it. 1 3/4 compared to 1 5/8. These are not in common denominator, so let me change. I need to be looking at 4 and 8, finding a common denominator of 8. If you doubled the bottom, you better double the top. So now I'm looking at 1 6/8 versus 1 5/8. We're in the positives, so 1 6/8 is bigger. That is a greater than sign. Number 3, Elliot and Shannon are both soccer goalies. Elliot saves 3 goals out of 4. I can write that as a fraction. 3 out of 4 for Elliot. And Shanna saves 7 out of 11. Who has the better average? Well, we need to be comparing these, but they're not in common denominator. So once again, I'm looking at 4 and 11. So I'm going to go to 44. Common denominator. So I took it times 11. I better take it times 11 on top. Took it times 4, so I'm going to take it times 4 on top. Now when we're in the same denominator, Elliot stopped more out of a common denominator of 44, so greater than. We would say that Elliot had a better average. Number 4, the lengths of 4 insects are 0.02 inches, 1/8 inch, and 2/3 inches. Oh, sorry, I missed one. 0.1 and 2/3. And we want to order these from least to greatest. Once again, the problem is you're seeing several different forms of numbers. So we're either going to go to all decimal or all fraction. I'm going to go to, well, I'll go both ways. So if I divided this one, 1 divided by 8 becomes 0.125. When I look at this 0.1, it's already a decimal, so I just need to do 2 divided by 3. Put out some zeros, goes in there 6, minus 18 is 2. I see that I'm going to be coming up with a pattern. Now when I go to decimal, I need to line up the decimal to compare it. So I had 0.125, I had 0.1, and I have 0.6 repeating. Then the important thing is you look from the left. I'm going to make sure I read this correctly. It says least to greatest. So I want the smallest one. These are the bigger pieces, so that's what I'm going to look at. There's my smallest one at 0.02. Okay, so I'm going to order them from least to greatest. 0.02 came first. The next one, well, 1, 1 and are both pretty small. This would be annex zeros. So I look at that. This one is your next one, so 0.1 would come next. Then would come this 0.125, which we know was the 1/8. And then finally would come the 2/3, 0.6 repeating. So that's the way to do it. That way, if we went to, if we went to a fraction, we'd have to go to common denominator. So I'd read this as 2/100. I'd read this one as 1/8. It's already a fraction. I'd read this as 1/10. Read this as 2/3. But now I'd have to find a common denominator for 100, 8, 10, and 3. Well, I can go to 10 over 100 for that one, so I'm in the common denominator. I can already tell which one's bigger out of these two, but that still doesn't work for 8 and 3. Actually, we'd be going up to like 1200, so I'm going to skip that stage, but we could go to, well, let me just go to 800 first of all, because 800 is easy to get to for all these, except that one, because that doesn't go in evenly, right? Times 8 times 8 times 100 times 100 times 8 times 8. Now this one's my problem because I can't go straight to 800. So I could take 800 times 3 and go to 2400. That would be times 800, which would be 1600. Now I'd have to take that times 3, which would be, this is a little bit silly, 240 over 2400. 2400 times another 3 would be 300. And 2400 times 3 would be 48. Now we're actually in a common denominator, so we can look at them for size. But that's a little bit ridiculous. I would say this time decimal was the easiest.